Hawkins. This is hopefully my lab 3 for Physics 2212. I was a little confused by all the links going to different places on the Canvas, but I'm pretty sure this is the one I'm supposed to be doing. So this is the circuits lab, the one that we did a lot of in class. So the purpose of this experiment is to predict the behavior of circuits containing resistors in both parallel and series form. That's pretty much what we've been doing in class for the past couple of weeks. We're going to be examining the behavior of capacitor and resistors using the voltmeter and ammeter to measure those currents and the potential difference across the circuits. The node and loop rule were satisfied. Our data really backed that up, and then we also found out that the RC was time dependent. Really simple principles used, loop rule, node rule, which is just what we've been doing with the nodes in is the nodes out, and then delta of the volt in a loop is 0, and then also Ohm's law, which is pretty standard. For the experiment, we were creating a series and parallel. We were creating both series and parallel circuits using the online virtual circuit builder, and then we were also using the in-class example for that. We were supposed to measure the potential difference in current using the voltmeter and the ammeter, and then graph those results. We had the 1.5 volt batteries, and the 2 different ohmage resistors. All right, so this was just, you have to define your system and your surroundings for an experiment. For us, the system is the circuit, and then the surrounding is everything else going on around the circuit. So getting into our data, we got for this first circuit, we made using that battery, we got 0.02 amps. And if you reverse it, obviously, it will show negative current. And then for the second one, using the voltmeter, we got 0 amps, and then 3 volts was what we set the voltmeter to. Here's just more data. I'm not going to go too in depth into all these values, but you can pause it and look at it if you want. The biggest thing is just to know that we measured the voltage in the different segments for this circuit, and then we can use there, you can see for the loop, we used the loop rule to show that our values are outputting what we'd expect them to output in accordance with the loop rule. So here's our calculations. They're essentially entirely based off of Ohm's law. With the 47 amp resistor, we got 0.96 amps over 0.02, right, which is getting exactly what we had expected to with the 47 ohms. The same happened for the 100 ohm resistor, and then we got 0 for the wire and 0 for the ammeter, which is also what you'd expect because those are current carrying and they're not going to be affected by resistance. Continuing on, here's the potential difference. It's just plotted on a rough sketch I made. So you can tell the difference in the wires is negligible, and then the battery, as it should, has a positive difference, and then resistors have a negative potential difference. The voltmeter shouldn't change current when it's connected, and that's because it has a very high resistance, so the current goes around it, and that's why you see that the voltmeter is not affected by the current. The second circuit we set up was for the node rule. It's exactly as you see right there. It's obviously important to note that it needs a negligible resistance in the ammeter, and that the current from the battery is split at the node, and then most of the current moves around the resistor because path of least resistance. Pretty straightforward stuff there. And then for the RC circuit, so not doing DC anymore. Whenever you connected the circuit, you'd see the light bulb kind of just make a flash, and then you'd see it dim almost right away. And if you took out the battery, then the light bulb would just light up because it wasn't having to charge through the capacitor. It was just immediately discharging it. Here's our graph. Everything's pretty much exactly what you'd expect. You can see how well it follows the least regression. We got 97% accuracy, so I don't think there's much I need to discuss there about inaccuracy. We were really happy with our outcome there. So for our what ifs, our big what if is, what if you charged the capacitor without a resistor? and that's just saying it's not gonna charge instantly. It would take more time. We couldn't get a good value when we were trying to measure it in person. But it is important to note that when we're using the actual ammeter to try to figure out what it was, you have to understand that the current reader is going to be lower than the actual current because of the resistance within the ammeter itself. And that's everything that went into our prediction for the what if question.